Morning, everybody. We're going to continue looking at some hypothesis testing today, and we're going to look at two types. The first one is going to be an extension of what we talked about last class, and then the one after that will be just a little bit of a different type of that. So what we're going to look at to start is we're going to be looking at two sample t-test or two sample hypothesis testing for comparing population means. So this is section 16C in that orange book. And basically what we're going to do is we're going to use the same process for last class, and we're going to use t-testing to compare across two different samples of data there. We're going to compare across two different samples of data. And so basically, if we have two means from samples, we have mean 1 and mean 2, basically what we're going to do is we're going to write our null hypothesis as we're assuming that these two means are equal from both of these data sets. That's going to be our assumption. You could also see this that if you did mean 1 minus mean 2 or mean 2 minus mean 1, those should equal 0 because that's just a manipulation of this equation right here, subtracting that over or subtracting that over. So you can see that either way. Now, we're going to follow the same general steps that we did before, but the main difference is when we're doing a t-test statistic for a two sample, in an IB, they do not ask you to do that by hand. We will strictly use a calculator to do so with a two sample t-test. And we'll go from there. So as a general rule of thumb, kind of just to refresh us on what we talked about last class, with hypothesis testing, the steps that you want to go in order for, and kind of just to bring this back up and refresh it for you all. The first thing we want to do is state the hypothesis. So the null, which says this is what the claim is, this is the status quo, and the alternative that is contrary to the null. After that, we want to state our significance level. And I just want to reiterate with the significance level that is the percent of risk of rejecting the null when it's true. So you'll usually see that anywhere from 1 to 10%. That is the amount of percent that you are okay with the null being true and you rejecting it. So then once you figure out your significance level, you're going to calculate your test statistic. So for for two samples, we're going to use a calculator to do so. Step 4, we're going to calculate the p-value, which is just the probability that the data the test statistic that we found occurs. If that probability is less than the risk of rejecting the null when it's true, we're going to reject the null, and that's only if the p-value is less than that significance level. And then lastly, if we reject it or we don't reject it, we're going to write a statement to interpret what the math that we did along the way. So let's look at an example. So we're going to look at example 3 on page 393. And basically what we've got here is we've got a pharmaceutical company developing a new drug to lower cholesterol. And so the reduction in cholesterol levels are shown below. So what we've got here, we've got the old medication. It's got a sample mean of 0.351, sample standard deviation of 0.058. We've got a new medication of 0.497 for the mean, and then 0.077 for the sample standard deviation. And what we want to do is we're going to conduct a two sample t-test to determine whether it's better than the old with a 5% significance level. So we're going to run through those 6 steps for a two sample t-test. So the first thing that we're going to do here is we're going to write our two hypotheses here. So the first hypothesis here, when it's a two sample, is that the null hypothesis says that that the means actually are not any different. The mean of the old is the same as the mean of the new. And I'm going to put that in words for you all real quick. I didn't do that as much last lesson. I want to do that more this lesson. So new medication is no better than the old. And what we want to check is see if this new medicine is better. So the alternative hypothesis here, and we're going to use mean 1 to denote the old, and we're going to use mean 2 to denote the new. So if we're checking to see if the new one is better, the cholesterol reduction should be higher on mean 2. So we're going to say that mean 1 is less than mean 2 here. And all that this is saying in words is that the new medication is better. And when you're writing those, you are welcome. You can put it in words. You can put it with the math notation, whatever you are more comfortable with. I like to put both just to really emphasize that we know what we're talking about. So after we do that, the problem here said the significance level. So the significance level that we were cool with was 5%, or it was 0.00, or not 0.005, just 0.5, excuse me. It's a little ugly, but it'll work. So now what we've got to do, we've got to figure out what the test statistic is here. So to do that, it's going to be kind of the same thing as what we did last class. We're still going to be operating out of stat for the next couple of classes because we're still going over statistics. So if we go over to test, we're going to be doing a 2-sample t-test. So what we need to not do, though, is not go to 2-sample z-test. Very easy mistake to do. Very easy just to look at that and say, oh, I've got it. I'm going to click the first 2-sample I see. So we're going to do a 2-sample t-test here. And so the old medication here is what we're referring to as mean 1 there. So mean 1 was was 0.351. The standard deviation for that was 0.058. And the sample size for that, the N right there, let's see, was 15 patients. And then for the second one here, the mean was 0.497. The standard deviation there was 0.077. And the sample size for those who got the new medication was 17. And so with that, we do have to make sure that our hypothesis here lines up with our hypothesis there. So I'm going to go with that the second one is, or that the old medication is less than the new medication right there. And so what we end up with here for our test statistic for T right there, T is going to be approximately negative 5.99, rounding that off to the third sig fig right there. So then for the p-value based off of that, so for step 4 here, our p-value right here is going to be 7.14 times, and that's just scientific notation right there. So we're going to say times 10 to the negative 7, which is a very, 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 very small p-value. Very, very small p-value. So the probability of a greater result would be 7, moving this decimal place over 7 spots. So we're talking a very small number. And so what we can say in step 5 is that because our p-value is less than 0.05, we have enough evidence to reject the null. Because originally, When we set this significance level, we said there's a 5% chance that we might falsely reject this null. But when we calculate this p-value, this is saying there's such a small chance, this is such a far out value that it outweighs this 5% chance. So we're going to roll with the p-value, and we're going to roll with the alternative hypothesis here. And so we're going to reject that in favor of the alternative here. And what that means, step 6, we need to write that out. So we accepted H1. So the new medication is going to be better based off of our statistical analysis, our 2-sample t-test. And so we're going to look at one more example here. And so I'll be honest, I didn't feel like writing all of this down. So the example that we're going to be going over is going to be number 2 from the book. I apologize if you would have liked to see it in Mr. Price's perfect handwriting. It just wasn't in the cards for today. So the problem we're looking at here is a researcher claiming on average high school students sleep less than middle school students. I don't know about that. I don't know. I'll have to talk to you all about that. So the researcher recorded the sleeping times of 49 middle school students and 55 high school students. For the middle school students, the mean daily time of sleep was 8 hours with a standard deviation of 0.2. For the high school students, the mean daily time of sleep was 7.9 hours with a standard deviation of 0.5. We want to conduct a 2-sample t-test to test the researcher's claim on the 5% level. And so we're going to do the exact same steps here, the same type of hypothesis testing. And so what we're going to say is, okay, so we're going to let mean sub 1, that's going to be the sleeping mean for middle schoolers. The sleeping middle schoolers mean. And we're going to let U2 mean mu2 be sleeping high schoolers. And so the null hypothesis here for step 1 is that mean 1 is equal to mean 2. That's the status quo. It's accepted that they're the same until someone comes and proves them wrong. And then the alternate hypothesis here that we're trying to prove here. So the researcher claims that high school students sleep less. So then that means that middle schoolers will be greater than high schoolers here. So this first statement says they sleep same amount. And this second one says high schoolers sleep less. And we're going to do some math based off of the data that we've got to prove that. Sleep less. So then the next thing that we're going to do is we're just going to state our significance level here. So the problem said at the 5% level, so 5% or 0.05 is our value for alpha. The next thing that we've got to do is we've got to calculate that test statistic. So again, I'm going to go back to stat over to test. We're going to go to a 2-sample t-test, not a z-test, and we're going to punch in some of this information. So I'm going to punch this in from the problem. So let's see, there are the mean for middle schoolers was 8. The standard deviation for middle schoolers was 0.2. We got a sample size here of N of 49. And then we're going to do the same thing for high schoolers. So high schoolers was 7.9. The standard deviation for high schoolers here is 0.5. And then the, let's see, the sample size of high schoolers here is 55. So our z-test statistic, hold on, let me make sure that I've done this fine. So we've got that the mean 1 is greater than mean 2, so I did not have that right. And let's see, so based off of that, let me make sure I've got everything punched in here correctly real quick. 8.2, 49, 7.9, 0.5, and 55. Yeah, so we're good. So with this, so the issue Mr. Price was running into, I'll elaborate here in a second. It is actually part of the notes. I kind of like that I messed up there. So what we're going to look at, so the t value here for our test statistic is 1.309. And so, or we're going to round that 3 sig figs. We're going to call that 1.31. And so based off of that, we've got a p-value here in step 4 here. So that area shaded to the right of that, the probability of getting a result greater is that p equals 0.0967. And since that is greater than this 5% that we were cool with, we're going to reject the alternative hypothesis. We're going to reject that alternate hypothesis in favor of the null. So step 5 here says that we're going to reject H1 in favor of the null there. In favor of the null. And so what that's going to look like when we accept that, when we put that into words there, we cannot conclude that high school students on average sleep less than middle school students. And we can't do this on the 5% significance level. So that right there is an example of two sample t-testing. And so I'm going to break these notes up today. So there will be another video for chi-square testing, just so that you all, because they are a little bit different, and I don't want you all to have to dig for those. I think I'm going to make them different videos today. But if you all have any questions concerning two-sample t-test, please let me know. Please shoot me an email or contact me through Zoom, and we will go from there. Thanks, y'all.